Hello class, in today's video we're going to be looking at the line of best fit. The learning intention for this particular video is we're going to know how to fit a line of best fit by eye and to know how to find the equation for the line of best fit. So firstly, I just want to briefly go over what scatter plots are. So we said that in last lesson that a scatter plot is a graph that we use to actually illustrate the correlation or the relationship between two sets of variables, and generally these two variables are related to one another. We said that these two variables are referred to as the independent variable. So this is the variable that kind of affects the other variable, and this will always be represented along your x-axis, whereas your dependent variable is always going to be represented along the y-axis, and this is the variable that is dependent or affected by the independent variable. So for instance, the temperature is always going to be the independent variable because this will affect the number of ice cream sales you made. That's why sales is plotted along the y-axis. Now, as I said previously, we said that each individual plot is actually represented by a circle or a cross on a scatter plot. But in order to kind of like better illustrate the actual trend or the correlation within a scatter plot, what we often do is we actually draw something referred to as the line of best fit. And this line of best fit kind of helps us clearly see the relationship between these two variables. So now I'm going to be talking in a bit more detail what the line of best fit is. So the line of best fit, also referred to as the trend line or the regression line. Now this word over here is probably more commonly used in VCA, so I'm just going to point that out for you guys. But essentially what the line of best fit is, it's just a linear line, a straight line that best represents the data on a scatter plot. What I mean by best represents is it kind of goes through in between most values in the data plot, and it's kind of like the average in this case over here. So, and we actually do this so that we can actually see the trend a lot better. The line of best fit is positioned in such a way that it's kind of close to all data values plotted along a scatter plot, but obviously this is not always going to be the case over here for instance, if you have outliers. But what it tries to do, it tries to accommodate for every single value, and it tries to be as close to it as possible, okay? And the reason why line of best fit is really useful is because we're able to actually make estimations for a particular variable from the equation, and there are two methods in order for us to estimate, and these are interpolation and extrapolation. So we're going to be looking at these two in the next lesson in a bit more detail, and I'll tell you guys what that means later on. So there are a few guidelines in order for us to create or draw the line of best fit. When you're drawing the line of best fit, you need to ensure that there's roughly the same number of data points found above and below the line of best fit. So essentially, you're trying to kind of balance the number of points below and above. So for instance, if I was to draw my line of best fit for this particular scatter plot over here, it would look something similar to this. And if I did it like this, notice that I've got 3 data points that are directly below the actual line of best fit, whereas I also have another 3 data values that are above the line of best fit. This one over here doesn't really count because this is kind of this data point kind of goes through the line of best fit, so it's found in neither side. So in this case, because I've got 3 below and 3 above, this is going to be a relatively decent line of best fit. What you also need to do is that when you do draw the line of best fit, you need to ensure that you do try to minimize the distance of data points from the line on each side. So what does that mean? So notice over here, what I'm trying to do is I'm trying to ensure that there's each data value is kind of have a similar distance on each side. So the distance between this point over here kind of balances the distance between this point. The distance between this point to the line of best fit is kind of balanced from this distance over here. So that's what I mean by this. So obviously it's not plausible to do this for every single data point, particularly for scatter plots that do have a lot of values, but this is one of the guidelines that you should try to do as best as possible when you're drawing your line of best fit. Other things that you need to consider or note down when you're drawing the line of best fit is that it doesn't necessarily have to go through the origin. So the origin is this part over here. So notice in this particular example over here, my line of best fit doesn't actually go through the origin at all. So it doesn't go through the point 0, 0. But also the line of best fit doesn't actually need to go through any data points at all from the data set. So in this case of here, the line of best fit doesn't really go through any points at all. This one just barely touches, but in this case, it doesn't have to, okay? So don't be alarmed if you draw your line of best fit and it doesn't go through any points. This can still be correct though. And lastly, if you do happen to have any outliers, so for instance, a value over here, you don't need to try to draw an outlier to accommodate for that, because outliers are not really supposed to appear in the data set at all. They generally occur due to luck or other external factors. So what I want you to guys do right now is either on the PowerPoint slide, what I'd like you to do now is I want you to have a go at drawing the line of best fits for these two particular scatter plots over here. So please answer this on the PowerPoint so you can draw the line. So insert a shape, draw a line, and try to make sure that your line of best fit has roughly the same number of points below and above the line of best fit as well. So please do that for both of these. But also try to answer this question as well. For this question, you can either have the choice of answering this directly on the PowerPoint or answering this in your exercise book. So what you're doing for this question is drawing the scatter plot, but also then draw the line of best fit on top of that. And after you've done that, for the previous textbook questions that you did for me in the last lesson, could I get you to please try to draw the line of best fit for each of the 4 graphs that you've done for me? So if you did all of this, this would roughly take around 15 minutes or so. If you've done this, we're now going to be moving on to the next part of today's lesson, which is about finding the equation for the line of best fit. Now, from this point onwards, class, it's going to become quite nerdy. You're going to be doing several calculations, and it's probably going to be the most difficult and challenging part of this whole unit over here. So I'm going to need you to put on your thinking caps on so that we can actually proceed on to the next topic. So you probably remember a bit of this from your year 9 studies already, but the general equation for the line, for any straight line, is given by this equation of here, okay? So it's given by the equation y is equal to mx plus c. And in this form over here, we refer to it as the slope-intercept form, but you don't really need to know the name of that. Now, what you do need to know is the variables that are present in this particular equation, okay? So you need to know what the gradient is, and you need to know what the y-intercept is, okay? The gradient is always going to be represented by the letter m, and your y-intercept is going to be represented by the letter c. To help you understand what I mean by the gradient is essentially the slope, or it's equal to the rise over run. So for instance, what I mean by that is if I was to look at these two coordinates over here, I'm looking at how far up did it go up by, so that's the rise. So in this case, I'm going up by 6 units and I'm moving by 3 units horizontally. So therefore, my rise over run is equal to 2, whereas the y-intercept indicates the position along the y-axis where the line crosses that position. So in this case, notice that the your straight line crosses through the point -3, so that's your y-intercept in this case over here. So what we're going to do first is we're going to try to interpret and solve this equation over here, because if you're actually able to identify your gradient as well as the y-intercept, later on when you do find the equation for the line of best fit, you can then kind of look back to see whether you've actually answered it correctly by just looking at the values and seeing whether these are plausible values or not. So firstly, this question wants us to identify the gradient as well as your y-intercept. So for the very first question, the gradient, remember, is always going to be the number in front of the letter x. So in this case over here, the gradient is going to be equal to +2. And your gradient and your y-intercept is going to equal to -1. For the second equation, your y-intercept is going to equal to -1. So in this case, when there's no number present, it's always going to be 1. And since there's a negative sign, it's going to be -1. And your y-intercept is going to be equal to +2. And for the third equation, your gradient is going to equal to -2. And your y-intercept is going to equal to -1. Once you've identified your gradient as well as the y-intercept, it's going to be relatively easy for you to actually match each equation to the respective graph, okay? I'm going to do the first one for you guys, and then I'm going to get you to do the other ones yourselves. So notice that for the very first for the very first equation over here, this is different from all the other equations because this one has a positive gradient, whereas all the other ones are going to be negative. All positive gradients, all positive graphs in this case, look something similar to this. So that will go in this particular direction, which kind of narrows it down to graph B in this case. So therefore, graph 1 is going to be positive B. But another way that I could actually determine whether this is correct is because I know that your y-intercept is equal to -1, and we can clearly see that over here. So this over here crosses at the position -1, which is why B is going to be the correct answer for equation 1. Have a go at identifying which graph corresponds to equation 2. So if you guys answer this correctly, it should equal to A, because we know that the gradient in this case is equal to, your y-intercept is equal to +2, and this over here is +2, your y-intercept. So therefore this is A, and therefore this is going to be equal to C in this case. Alright guys, what we're going to be looking at now is how do we actually find the equation for the line of best fit. So the first step that we need to undertake is we need to actually find the gradient for the line of best fit, okay? And in order to do that, what we need to do is we need to identify two easy coordinates that must lie on the line of best fit, and then we actually calculate it by using the formula m is equal to y2 minus y1 over x2 minus x1, okay? Now, this over here might look confusing to you, but in this case, each of these values just represents coordinates in this case. So x1 and y1 is one pair of coordinates, whereas x2 and y2 is another pair of coordinates, okay? Before I actually show you how do we actually calculate this, I do want to tell you guys about some of the common mistakes that I often see that students make for this particular topic, okay? So when they're trying to find the gradient for the line of best fit, the first common mistake that I often see is they actually use coordinates that are not on the line of best fit. What do I mean by this? Well, they might actually use these two random points over here that are not even on the line of best fit. It needs to be on this red line over here. So that's the first mistake I can say. So these two coordinates are not on the line of best fit, so therefore your equation will be automatically incorrect. Now, the second common mistake that I often see is that students often use inaccurate coordinates, or they actually round up the coordinates. So to see what I mean by this is look at these two coordinates over here. So in this case over here, notice that this one over here is not exactly along this particular grid line over here. So what they might say is, okay, this point over here is equal to 1 to 12. And we know that this is not true, because if you look closely, or if you had really good vision, you would notice that the y value at this particular coordinate over here is just slightly under 12, so that we can't actually make that approximation. Similarly for this one over here, another common mistake students might say is that, okay, that's kind of halfway, so therefore the coordinate for this position over here is going to equal to 8, 5, okay? But if you look very closely, this is not really midway at all. It's slightly above that, so you cannot say that this the y value for this particular coordinate is equal to 5. So that's the common mistake that I often see. And if you do make this silly mistake, then I want you to slap yourself. Not really, just kidding. But please don't make this mistake, because you will get the incorrect answer, guys. Now, once you've actually correctly identified what two pairs of coordinates that you're going to be using, what you need to do is you just only substitute one of those two coordinates into the actual equation so that you can find the value of C, meaning find the value of your y-intercept. So let's firstly look at how do we calculate the gradient, and then we'll look at how do we actually calculate the y-intercept for the line of best fit. So remember, the gradient refers to the slope of a straight line, and there's 4 types of gradients. There's going to be a positive, negative, 0, or undefined. We say that something is positive is when you go from left to right, the y value also increases as well. When something is negative, when you go from left to right, this increases, but along the y-axis, this will decrease. 0 is when you don't actually have a change in the rise at all. So remember, the gradient is rise over run, so you're not rising, so that's why the slope is equal to 0. And this is undefined because you're not running anywhere at all, so therefore 0 is going to be on the denominator, and you can't divide any number by 0. You don't really need to know that at all, but the most important part is knowing how to calculate the gradient, which is y2 minus y1 over x2 minus x1. And I do want to emphasize this again, which I previously showed you beforehand, but whenever you're finding the gradient, please ensure you are choosing any 2 points that must lie along the line of best fit. So for instance, if I was to find the gradient for this particular example over here, I'll be choosing these 2 points, okay? Because these two coordinates, although not one of them is not exactly part of the data set, these two coordinates lie along the line of best fit, which is why I'm going to be using them to find my my gradient. So I'm going to go through two examples over here, guys. So if I was to find the gradient for this particular line of best fit, I'm going to be choosing these this coordinate over here, which is 0, 4, and this coordinate over here, which is 5, 2. Once I've identified two coordinates that are on my line of best fit, I'm going to label each of my coordinates as x1, y1, x2, y2, okay? And it doesn't really matter which way you go, but I always go from left to right, x1, y1, then x2, y2. What we do then is we need to substitute these values into the formula. So in this case, 2 is equal to y2, so I'm going to substitute 2 here, and my y1 value is 4 in this case. So it would therefore be 2 minus 4. X2 is equal to 5. 5 minus 0 in this case. So if you did this correctly, this is what it would look like. I'm now going to simplify my formula. So therefore, 2 minus 4 is equal to negative 2. And 5 take away 0 is equal to 5. So therefore, the gradient for this particular line of best fit is equal to negative 2 and 5. I could further simplify this by finding what this is as a decimal. So if you really wanted, then this would equal to negative 0.4, but you don't have to put it as a decimal. But for some of you guys, it might be helpful to put it into a decimal for you to later on calculate the y-intercept. Let's look at another example of how we can calculate the gradient. So in this case over here, I need to choose two coordinates that lie along the line of best fit. This one's a bit more trickier because I don't really have nice values. I'm going to be choosing this one over here, and notice that I am approximating, okay? So in this case, I know that this isn't exactly where 2 is. So in order to accommodate for that, I just have to make a value that's slightly less than 2, which is in this case equal to 1.9. So I'm using 2.2 and 1.9 in this case, and I'm also using this value over here. So once I've got my two coordinates, what I do is I label them as x1, y1, x2, y2, and then substitute it into the formula. So therefore, it'll be 3 minus 1.9 over 3.5 subtract 2.2. Simplify this on your calculator, and if you did this correctly, then you're going to get a gradient roughly equal to 0.85. What I'd like you to do now is I want you to have a go at attempting this question. So for the very first part of this question, I want you to find for me what two coordinates would you actually use to find the gradient for this particular straight line. So please pause this video and have a go at answering this question. If you answer this question correctly, then you could actually be using this coordinate, this coordinate, this coordinate, this coordinate, or this coordinate. So these are 5 relatively easy coordinates that you could be using in order to find the gradient. So any two from this list is going to be an appropriate coordinate that you could use to calculate the gradient. Okay class, now that we've already identified some of the appropriate coordinates that you could use to find the gradient, I want you to have a go now of calculating the gradient for this particular question. Now if you guys done this correctly, what I'm going to be doing is I'm going to be using these two coordinates over here to find my line of best fit. You may use other coordinates, but as I said, I'm using this one. It's quite subjective, and the reason why I'm using these coordinates rather than the other ones is because any coordinates that contain a 0 is always the best choice, because when you simplify it, it's just a lot easier, okay? So I'm going to choose these two coordinates over here, and I've already labeled them as x1, y1, x2, y2. All I really do now is just substitute it into the formula, and if I did this correctly, remember, two negatives make a positive, so 1 divided by positive 1.5 is going to equal to roughly 0.67, okay? And if you use any other coordinates along the line of best fit, you should get a very similar answer to mine. Alright guys, what we're going to be looking at now is how do we actually calculate the y-intercept, and then lastly finding the equation for the line of best fit. So as I said, there are 2 steps. What you need to do first is find the gradient and then substitute the coordinate in to find the y-intercept and find the actual Now that we have already learned how do we calculate the gradient for the line of best fit, we're now going to be looking at the last part of today's lesson, which is finding the y-intercept so that we can actually generate an equation for the line of best fit. So as I said, the first step that we always do is find the gradient. So let's look at another example up here. In order to find our equation, firstly find the gradient, okay? So in this case over here, if I was to find out my gradient, then I'm going to use these two coordinates over here, and I'm going to label this as x1, y1, and I'm going to label this as x2, y2. I'm going to go through two examples so that you guys have a better understanding. What I'll do next is I'm going to find out what the gradient is going to be. So if I was to find out the gradient, it will be 2 minus 4, because that's y2 minus y1, over 5 minus 0. Simplify this. This is going to give me an answer of negative 0.4, okay? So what I'll do now is, in order to find out my y-intercept, what you need to do is substitute the gradient into the equation. So this is the equation for the line for a straight line, and I just substitute the gradient in. So I can substitute either the fraction form or the decimal form. It doesn't really matter at all. After you do this, then you need to actually substitute a coordinate found on the line of best fit so that you can rearrange to solve for C. Now that sounds complicated, but all you really need to do is substitute one of these coordinates over here that you used earlier on to calculate your gradient, okay? And you always want to choose the easier or the most simplest coordinates. So anything containing a 0 or a 1 is always the best choice to go for. So in this case, I'm going to be substituting in 0, 4. So if I substitute 0, 4, 0 goes wherever x goes, and the 4 goes wherever the y goes. So it will look something similar to this. And we know that in this case over here, because there's no symbols between the negative 2 and 5 and the 0, this means I need to multiply these two. And you should already know that any number multiplied by 0 is equal to 0. So therefore, your y-intercept is going to equal to 4. So C is equal to 4. And all you really did to get from this to this is I've just substituted that 4 into this equation of here, which is why this is going to be my answer for this particular example. Let's look at another example so that you have a better understanding. So in this case, again, when you have this as your graph, what you need to do is find the gradient. So I'm going to be using these 2 points over here, and we've done this previously in the other example. So we said that the gradient in this case was equal to 0.85. Once you find out what the gradient is, substitute the gradient into the general formula for a straight line. So therefore, it's going to be equal to y is equal to 0.85x plus c. What we need to do is find the value of c. So I'm going to substitute a coordinate that I used earlier on to find my gradient. So therefore, always choose the easiest one. So in this case, I'm choosing 3 and 3.5 because these two have ugly as decimals, and I don't really want to bother with that. So in this case, if I sub in 3 and 3.5, remember this is your x value, this is your y value. So wherever I say y, I substitute 3.5, which I've done over here, and I sub x as 3, which is how I got this particular equation over here. All we need to do now is just simplify it. So in this case, multiply these two numbers together, and if you did this, you're going to get an answer of 2.975. We want to find out what c is, so I need to get c by itself. I need to get rid of this guy. Because this value is a positive 2.975, I'm going to subtract both sides by 2.975. And if I do that, then I'll find out that c is therefore going to be equal to 0.025. So that's my value for my y-intercept, okay? And lastly, once I find that in, I just substitute c back into this particular formula over here. So the equation for the line of best fit for this particular example is equal to y is equal to 0.85x plus 0.025. As I said earlier on, this is going to be quite nerdy. So all these calculations might be complex, but if you guys did a lot of practice, you eventually get it. Just a little reminder that everyone's equation for the line of best fit may be slightly different, okay? And the reason why it will be different, or there will be slight variations, because you might be using different coordinates, or you might be using different approximations when you're choosing the coordinates that you've selected to find out your gradient, okay? So, and I do want to mention that it is perfectly okay and you can still get the right answer given that you did the correct working out. So don't be too stressed if my equation looks different from your equation, okay? Okay class, now I want you to have a go at finding the equation for the line of best fit shown over here. So firstly, try to find the gradient and then find the y-intercept so you can construct your equation. Please take your time at doing this because this is a very challenging topic that most students have. So give yourself 10 minutes or so at answering these questions and then compare your answers with my answers. Now, firstly, when you're answering this question, please again try to find two coordinates that are relatively easy so you can find your gradient. So in this example over here, I'm going to be choosing these two coordinates over here because firstly, they fall along the line of best fit, but again, any values that include 0 is always the way to go. So in this case, once you've done that, then I can find out my gradient, okay? So I'm going to label this as x1, y1, okay? And I'm going to label this as x2, y2. Once I've done that, I just substitute the values in. So whatever y2 is, which is in this case 0, I then subtract it by 1, and etc, etc. So if you did this correctly, you should get a gradient which is very close to, in this case, 0.5. You might be using different values, which is why your values might be slightly different, but it shouldn't be different by that much though. Once we've actually calculated the gradient, then we can actually start finding what your y-intercept is going to be. So now we're going to solve for C. So what we do now is we're going to substitute one coordinate that we used earlier on to calculate the gradient to find your y-intercept. So in this case over here, I'm going to be using this coordinate over here. So I'm going to substitute this coordinate into the equation. So wherever I see x, I'm going to replace it with a 0. And wherever I see y, I'm going to replace it with the number 1. If we did this, this is what it should look like. And we know that any number multiplied by 0 is equal to 0. So therefore, if you simplified it, C or the y-intercept is equal to 1. And we can kind of see that readily over here. So this over here, the position where the your line crosses the y-axis is also equal to 1. So therefore, substitute this in. So therefore, your equation for the straight line is now going to be equal to y is equal to negative 0.5x plus 1. So I'm hoping that you guys have actually answered this question. If you didn't, then don't worry too much because we're going to be spending today's lesson as well as the next lesson trying to find the equation for the line of best fit. The only questions that I'm going to be getting you to do is just these three questions over here. So I want you to have a go at finding the equation for these three line of best fits. That's pretty much the end of today's video. Hopefully this video helped you. I'll see you guys again in the next video. Bye.